Morning, everybody. I have to say it's oddly appropriate to have a lot of time uncertainty around a talk that's going to involve time travel. I'm pretty sure this is the timeline where Loki escapes. Right, so I'm going to talk about sedimentology, and what I'm constraining myself to is really the industrial employment in sedimentology over a certain time frame. And one of the things that's important to note is that we all have biases. There's actually a whole talk about biases yesterday in machine learning and geologic prediction. It's actually been somewhat of a theme of this meeting. We all have cognitive biases, and one of the biases that's really important to understand is one called status quo bias. And what status quo bias is a really interesting one. We set a price on any change. In our heads, it's cheaper to stay the same than it is to change, no matter what that change looks like. And this pervades all kinds of decision making. In fact, this goes back to Samuel Johnson, who had the famous quote, "To do nothing is within the power of all men." It is possible to do nothing for everybody. Everybody has that in their capabilities. My suggestion is it takes courage in overcoming this bias to actually make a change. And we need to think about changes over the future of sedimentology. Speaking of changes, when I actually started putting this talk together, long after putting in the abstract, as you normally do for AAPG, I started thinking 50 years might be a little ambitious. 50 years is beyond the time frame of any of our careers in this room, and I thought 30 years was actually a pretty good time frame. In fact, this was the time frame that was used in the science fiction movie Back to the Future, where they went back from 1985 to 1955 and then forward to 2015. Yes, that was several years ago, believe it or not, that they went forward in time too. And I thought, well, 31 years was a pretty good time frame for a variety of reasons that you'll see in just a few minutes. So one thing that's really important about any kind of prediction of the future is that if you watch any of these videos from the 60s or 70s or 80s or even before talking about predicting the future, they're hilariously wrong in detail, but often right in shape. And I guarantee that all my predictions will also be generally right in shape, but hilariously wrong in detail as well. So, just carrying on from the example of Back to the Future, they predicted that we would have video chats. That's good. We do this all the time. They also predicted we have flying cars, which to my disappointment we do not have. And they also predicted that the Cubs would win the World Series in 2015. This is obviously totally wrong. They won it in 2016. So this is what it is. So, often the shape is right, but the detail is wrong. So let's go back 31 years to 1988. Believe it or not, I had to do the math to realize that was 31 years ago. And what were we doing in 1988? What were the industries that were important at the time? What were we thinking about? What were we doing? One of the things we were doing is smoking on airplanes. This was the year we banned, for the very first time, smoking on airplanes for flights, domestic flights of 2 hours or shorter. That was the first step, right? And, try to explain to your kids, or if you don't have kids, go find one, and try to explain that we used to smoke on airplanes. We used to lock ourselves in a metal tube in the air, and even if you weren't smoking, you were still smoking because the air is cycling through on this airplane for the entire flight. You're lighting fires on airplanes. I mean, you can't even carry a water bottle on the airplane now, right? This is ridiculous that we are smoking on airplanes. But this was incredibly controversial to ban smoking on airplanes, despite all the common sense associated with it. It was so controversial, actually, that somebody suggested a smokers airline, and this actually attracted quite a lot of investment in 1988. So this was an airline specifically for smokers. Again, try to explain to your kids that there was a smokers airline proposed in 1988. Now, then again, if you propose to them that you should have a marijuana-themed airline now, they'd be like, yeah, Dad, that's a smart business idea. You can call it Sky High Airlines or something, it'd be great. So, the world changes over 30 years quite a bit. I don't even know what that was. Okay. And, the other things we were doing back in 1988, we were watching video cassettes. We were going to stores and renting them and having to rewind them before we brought them back. Again, try to explain that to kids today and they think you're crazy. Why would you go to a store when you could just download the movie? But those kinds of things were inconceivable, really, at that time, or perhaps within conception, but nobody was going to build the infrastructure to allow everybody to download videos. I mean, the internet as we know it didn't even exist at this time, right? We were also, last Back to the Future reference, I promise, we were also going and buying 36 exposure rolls of film. Oh, the video, it's not working. we were buying 36 exposure rolls of film for like $8 and then having to go and develop it for another, $8, $10, and you take it 36 pictures and you have 36 pictures off your roll of film, right? In the world of digital media, this is again sort of ludicrous that we ever did this, and kids don't really understand it. So what happened over the next 30 years, right? These were big businesses, big things, not small things. So in one of my favorite tweets of all times, one of the big video rental places was Blockbuster, as most of you know. This is a tweet from Blockbuster in 2011, not that long ago, asking people to tweet why they're leaving Netflix, and they'll win a 1-year subscription to Blockbuster if they manage to come up with a good answer, right? This is not that long ago, and it seems utterly ludicrous because the people running Blockbuster didn't understand how fast things were going to change. And what they did was they basically destroyed the business. They were too late to change because they were too invested in the status quo. They had an understanding of their business worked and made money, and they wiped about $8.5 billion off of their value in that time. Netflix is now worth $154 billion. They started from nothing at the time. Blockbuster was still not able to figure this out, right? As another example, carrying on with this is one of my favorite pictures on the internet. This is Kodak at its relaunch on the New York Stock Exchange after going bankrupt and being delisted and coming back. And here they are on stage at the New York Stock Exchange using the thing that killed Kodak, camera phones, to take pictures of the moment, right? Because Kodak, if you're not aware, they invented the digital camera. They weren't able to pivot quickly enough into digital cameras. They pivoted in consumer cameras and built up a good market share in that pretty much just in time to be wiped out by camera phones. So what they managed to do was they took a market cap of $30 billion and they wiped it down to basically zero. And the difference between $30 billion and $100 million is basically zero. If I gave you $30 billion today and say, please get rid of this as quickly as you can, you would probably not be able to do it as quickly as Kodak was able to do, right? It's actually hard to do. It's hard to wipe $30 billion of value off of a company, unless you're Elon Musk, I guess, right? So, there's a lot of changes that have happened over this time because people have been invested in the status quo and they don't see the change coming. So what's coming next? 31 years from now is in 2050, and I'm going to go into predictions now, and just as a reminder, I hope to be right in shape, but I will certainly be hilariously wrong in detail. So in 2050, here's the oil curve, here's the oil demand curve as predicted going forward. This is our own predictions, which are available out on the internet. You can look at anybody's. You would like to look at Woodmax, whoever. Everybody more or less has the same peak of oil consumption happening right around here, which is 2030. 2030 sounds like a really long time off, but as a reminder, that's 11 years. I'm talking about 30 years, we're talking about 50 years. On the last couple talks, we've seen predictions out to 2100 or 2200 in the case of Zoltan, right? So 11 years is peak demand. Now don't get me wrong, there's a tremendous amount of money to be made in oil and gas over this 30 years. I'm not saying the industry is going to disappear overnight, anything like that. Just to get to that level of demand and to continue to fill the dropping of that curve is a whole lot of oil and gas. Oil, I'll say in this case. But my point is that this could happen sooner. It could also happen later. But at the time you start dropping demand, you change the entire investment climate in oil and gas. We are quite happy to invest long-term capital in this business right now. As soon as you go into a decline with an uncertain future, long-term capital will start drying up. It won't disappear. There's still a lot of money to be made, but increasingly this won't be seen as a growth industry, something that people would like to spend their time in, right? So in addition to that, there'll be changes over this time period as well in what we do in sedimentology, and I'll get to that. So I'm gonna go through a few job ads of the future. This is in 2050 when obviously we'll still be using newspaper classified ads, I guess. Hilariously wrong in detail, right? So here's one for a sedimentologist needed in 2050. It says, for reservoir characterization, some travel required. Well, that sounds interesting. I'm a sedimentologist looking for a job in 2050. Let me call them up or whatever, video chat or whatever it's going to be in 2050 and see what this is about. And what it turns out to be is sedimentologists needed for reservoir characterization of water ice and lunar sediment. I don't know if any of you saw Jeff Bezos' announcement a couple weeks ago. That's where this slide is from, on Blue Moon. He, under Blue Origin, is planning on sending a mission and ultimately build a permanent base in Shackleton Crater for the express purpose of mining lunar water. Now, this sounds like science fiction. This sounds completely inconceivable. Jeff has been working on this for some time. Blue Origin has been around for a long time. Those of you who have been locked out of the deep water outcrops in West Texas, by the fact that Jeff bought all that stuff up a couple decades ago, tells you how long-term his ambitions are. This is not a guy who invests in things lightly. And if you don't believe me, Warren Buffett just gave him $1 billion the other day as well. These are smart businessmen who are investing in this future, right? And I will tell you, none of these guys know they need sedimentologists. This is what they have. They know that there's water ice in Shackleton Crater, and they know they want to get it. This is water in pore spaces in sediment. It's not the kind of sediment we're used to, but they think this is an engineering problem. And we've kind of heard that story before in the oil and gas business, right? Once you're starting to characterize flow through porous media, you really want to have a geologist and preferably a sedimentologist involved. This stretches the definition of sedimentology, I know, but it's up to us to stretch that definition and to look for new opportunities to do new things. So whether you believe this is a business or not is really up to you. What this is being driven off of is the incredible drop in launch prices. The cost to send a kilogram to Earth orbit has dropped by an order of magnitude over the last few years, down to $2,700. It's $2,700 to launch a kilogram into orbit. You can go launch your own satellite right now for about $20,000, including building costs, right? This isn't a big deal. The accessibility of this market is booming. The economics and what Jeff is looking at, excuse me, is this math, and I won't go through this in detail, but the bottom line is if you're mining water from the moon and getting it into Earth orbit here, the cost of that is a tiny fraction of sending it up from Earth. It is way, way, way cheaper to mine propellant and resources in space than it is on Earth. And if you don't believe me, there are people actually working on this. A couple people that are worth following up on this work, Lindy Elkins-Tanton, who's PI on the NASA Psyche mission and head of the Department of ASU, of Earth and Space Exploration, and Angel Budin-Madrid, who actually is leader of the Space Resources Program at Colorado School of Mines. That's who that slide came from. And in case you're not aware, Colorado School of Mines has a program with multiple professors in it explicitly for space resources. You can go get a degree in space resources today from Colorado School of Mines. This is not science fiction. These are things people are thinking about and planning businesses around today. So it's easy to sit back in 1988 and think it's never going to be possible to build an online streaming system that's going to serve millions of people and creating its own content. That's not how the world works. And it's easy to sit here today and think, this isn't how the world works today. It's not going to be the way the world works tomorrow. We as humans like to think things continue on indefinitely, and they don't. They change. And this is one of those things that will change over the next 30 years in significant ways. Continuing on with some of the ads, sedimentologists needed for microplastics mitigation company to characterize high concentration areas of plastic deposition. Zoltan mentioned this in his talk earlier as well, the understanding of plastics. This is Ian Kane's work on the Scampi project, and what Ian has recognized and looked at is that there's a lot of microplastics down in the sediment in deep water. And what they've actually started to do is understand from a sedimentological perspective where that comes from. This is almost like source to sink for plastics, right? Where does plastics come from, and then where do they end up in the subsurface, in the offshore environment, in the sediment, right? This really takes a fairly sophisticated understanding of sedimentology to be able to predict. If you're going to try to mitigate this at any time in the future, you will need sedimentologists in order to do that. It's going to be a different kind of line of work, but quite interesting. And I would suggest if you want to learn more about this, you follow Ian Kane and his work on the Scampi project. Now, as a quick editorial, I keep showing these Twitter profiles, and one of the things that's neat about Twitter that I really appreciate is we are all complex people with lots of interests and diverse interests. And if you follow Ian Kane on Twitter, you'll not just get all the stuff on his latest deep water stuff, you'll also get, as you notice, he's a bass player, and he's also a mountain biker. And you get the fact that we are not all just scientists studying science and doing nothing else in our spare time. We actually have interests. And it's good to see that. It's good to kind of see that people are complicated and have multiple interests because it makes us a little more human. Finally, sedimentologists needed for a small QC group in a major energy company. This requires experience and computational interpretation. This, again, sounds like something that you could see today, right? This is an ad that you could note today. This is still in 2050. But what's different about this? What are we going to be doing different in the oil and gas industry in 50 years? This time last year, I was talking about seismic data at the GeoSoc and our work on predicting seismic horizons using deep learning, doing seismic interpretation during deep learning. And I said in that talk that nobody should panic. This is a long way off. We're still working on it. Computers aren't going to replace you in the short term. After a year more work, I'm starting to think a little differently. I'm going to show you a little bit of that work now. So here's the seismic line, and those of you who are clever seismic interpreters can see the key horizons very quickly on this. If you use the tools we normally use, you know, try to auto-track stuff. And, you know, auto-tracking never really works very well unless you're doing like seabed or something simple. If you're going to do something complicated, you know, it breaks up and doesn't really give you a complete picture, and you end up spending more time fixing it than you do actually doing it from scratch. So our workflows now more or less do this from scratch rather than using auto-trackers. Well, now we have a neural network that's quite happily predicting these across the volume, and I'll just flip back and forth really quickly between the auto-tracker and the neural net, and these have been given exactly the same input, as you'll see in just a minute. And you can see that the neural net is doing a much better job, actually, than the auto-tracker, and not very different from the labeled truth. The horizons are in the right places, misses some in a few places, but it's doing a pretty good job. And if we look at that map view, it's doing actually a remarkable job. So if you look on the far left, that's the auto tracker, taking a relatively deep horizon. Don't let anybody fool you. A lot of people show shallow seismic data and predictions of using neural nets because it's the easy place to do stuff. It's like auto tracking on the seabed. If you only showed auto tracking on the seabed, you would think it worked really well. So when you get down to deep horizons, things get difficult. So on this horizon, this is fed just a few inlines of interpretation, and it does an auto tracking around the volume. This is quite a big volume, as you can see in samples. Here is the neural net, and the neural net makes actually quite a complete map of what's going on. Much, much, much better job than an auto tracker. If you look at the one on this side, you've got another auto tracker that seems to be doing a complete job, but this surface is actually erosionally truncated. And you know, as is typical with auto trackers, it doesn't know anything about truncation. It'll just happily continue on its merry way in its interpretation. And so this whole bit is false interpretation. This is like a false positive right in here. Whereas the neural net will quite happily stop there, because it understands it should stop there, right? Yeah, this is happening, people. This is something that I would have thought a year ago was science fiction, and now we have neural nets that are vastly outperforming auto trackers. Think of it as like an auto tracker that really works, and we have that right now. And so it's better both in false positives and false negatives than an auto tracker, and arguably better than humans in some ways, because it is actually consistent. Whereas one of the challenges of this is training these big neural nets off of inconsistent human interpretations is a real challenge. Maybe getting a little bit closer to sedimentology, we're also using neural nets to describe cuttings. So we have a project, this wasn't me, these are my colleagues at work. They made a system to basically take pictures as things come off the shaker and make lithology predictions on this. And it actually works really well. It works fine. We've been in the process of moving our ops geologists onshore, and this is just another nail in the coffin of sending ops geologists offshore under normal routine circumstances. We don't need them to sit there and scoop cuttings off the shaker and describe them in most cases unless there's a really specific need. It also means we can really use this data, but that's not really the point of this talk. If you look at how well this worked, it actually predicts about 85% of the time. It works pretty well. And where it fails, actually, is where you sort of expect it to fail, or maybe the splitters have gotten involved in describing things. It has a hard time telling the difference between sand and silty sand. Okay. I'm okay with that, right? Because if you really need to discriminate that, yes, you need a geologist, and you probably need a microscope or some other way to actually analyze these cuttings. Under normal routine operations, you don't need a geologist. And what I would tell you is, if you are doing any kind of interpretation task that involves recognizing a visual pattern and making an interpretation off of that, that will not be a job in 2030. We will have neural networks or something fancier that will do that, because there's a lot of things out there that can do that today, and the only reason they're not doing it today with existing technology is nobody's really tackled the problem yet. By 2030, these things won't exist. That doesn't mean we don't need sedimentologists. We need people who actually understand what's happening in this to guide the computer when it goes wrong, to understand where it can't make a decision, and to actually make new predictions where the computer has never seen before. This is the job of a sedimentologist. This is the job of a geologist. This is the job of a scientist. These things don't vanish. Oil companies will still exist. They will still need these people, but you can imagine the workload is fundamentally different than it is today. You don't have lots of people going click, 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 getting RSI, interpreting seismic, or spending lots and lots and lots of time describing core. Most of that is routine and analyzed by the computer, except where it goes wrong. And that's where you need people to come in with good knowledge of what's going on, and good knowledge of sedimentology, and good knowledge of geology to actually do the hard work. But the great thing about that is, then we're spending time doing what we love. We're solving hard problems and understanding the subsurface rather than routine rote work. So just to bring this to an end, there are lots of other jobs I can come up with. I thought Zoltan did a good job of sketching some of these out earlier. Large-scale geoengineering, if you're trying to design and protect cities against rising sea level, there's a whole bunch of sedimentology to be done in that process. There's a lot of stuff in geohazards, as we saw from the previous talk. There's a lot of things I could get into that are interesting. I'd like to hear your thoughts, so feel free to come and talk to me afterwards. Maybe you're in a hurry to get to lunch, but we can talk anytime. Send me an email. I'd love to hear your thoughts on what the jobs of the future are. But I would ask, going back to the beginning of the talk, which is safer? Based on what we know of the last 31 years and how dramatically things have changed and how entire businesses have been destroyed and entire new businesses have been created, is it safer to assume, as we would all like to, that things are going to be more or less the same? Or is it safer to assume things will be fundamentally different? I would argue that the Back to the Future case, where they went back to 1955 and laughed at how sort of backwards they were in 1955 versus today, or going back to 1988 and laughing about how people were smoking on airplanes, that's how we'll be seen in 2050. Sedimentologists will still be needed. The opportunity to do new things, whether it's in space or on Earth, still exist and are actually expanding. But it's up to us to redefine that definition and push those boundaries of where sedimentology has an impact. Oil and gas, I think, will still be around, depending on how fast that decline happens. Maybe it'll be different. I think we're going to see fundamental changes in the kind of work a sedimentologist does in the oil and gas industry. And it's very fashionable now to talk about how everybody needs to be a programmer. Over the next 30 years, the changes to what we're going to do and what we have to learn are much, much greater than everybody needs to be a programmer. Based on what I've said, we need to be scientists. We need to be able to think critically about the subsurface. We need to be able to think critically about a problem. And if you're in the business of training students today, I would argue it's worth thinking about what kind of skills you want to teach them for tomorrow, and not just assume the world is going to be as it is today. So, going back to the first quote, things change. And as Samuel Johnson said, to do nothing is within the power of all people. Poor Samuel Johnson, he wrote the first English dictionary, and now he's a meme that's on the internet for kids to laugh at. This is a really common one you see. If any of you have kids that are into memes, you'll see this all the time. Poor guy was a great scholar, and now he's a meme. Things change, right? Thank you very much.